Okay, so now we try to exploit another very interesting aspect that is associated to the humans, and the aspect is the fact that the humans could solve a lot of things in parallel. So let's say, what are you doing right now? So I'll not mention anything called as states. I'll just say the actions that you are applying. You are watching AI videos, and of course you know that after watching AI videos, what do we do is the fact that there is a assignment in AI, and once you do the assignment in AI, you also get in a tutorial on AI. And once you've done all of it, you are done for the week. That's what I say is your job is what's done. Now, in order to complicate the problem, what I do is that I say that there is, of course, a sister course running in parallel. So you need to again watch the machine learning videos, do the assignment related to the ML course given by its instructor. You also have the tutorials of that. And then you finish. Now, you've got 1 week times and you've got these 6 things to do. You know you could do that in any order. The only thing you cannot do is to do the AI assignments before watching the AI videos, because then you don't know how to do it. And what you cannot do is to the AI tutorials either before watching the AI videos, because then you don't know the theory part of it, or to do it before the assignments also say, because then you don't have the practice to do the tutorial and you won't be able to do that. Similarly with ML, now what classic planning systems will do is to waste a lot of time in saying, first do I do this, then do I do this, then I do this, then I do this, then I do this, then I do this, which one of the two things that you do. And the humans do 10 projects in parallel. You're studying 5 courses in parallel. You are also doing a project in parallel, which is another course. You have different life missions in parallel. Your brain keeps on doing things in parallel, and because it knows this is the sequence to be followed, as long as you don't break that sequence, you can do things interchangeably. Your ideal depth is 3 over here, depth 1, depth 2, depth 3. While what classic AI says, remember it's still exponential, the depth is 6 for 2 courses, 9 for 3, and so on. It completely increases depth and wastes time. So can I solve something like this? Can I solve something like this and then linearize it? Linearizing is just a topological sort. So AI videos, ML videos, assignment AI, tutorial AI, assignment ML, tutorial ML, finish. So instead of searching for this, instead of planning for this, can I instead plan for this? And the answer is yes, you can do that, but the first time you might be looking at a problem where the output is a graph. This is the output of a planning algorithm. So when was the last time you've done a lot of graph searches, you've done a lot of CSPs, you've done a lot of intelligent algorithms? When was the last time you saw a problem where the input is a classic problem specification, action functions, initial, goal conditions, blah blah. However, the output is a graph. So it's searching in the graph space, or it's searching in the planning space, which is also what makes this algorithm a little bit more weird. But we'll be looking at this algorithm very briefly, now just to tell you what the conventions I have already followed here, the caged ones are the action names and the arrows are what are called as the temporal constraints or the ordering constraints. So the ordering constraints come in this topological sort, that what can I do before something else, what can I do, what I cannot do before something else. Those are the temporal or the ordering constraints. And if you need to write down the classic states as in the propositional literals, then the preconditions would be written here above the action and the effects would be written here below the actions. So the precondition would be above the action, the effects will be below the affects. The start is a special action which is always the first action to perform, and so that's a problem. Backward search, we said we'll start off from goal which will be there and then we'll go on expanding. Forward search, we'll start off from search and we'll go on expanding. Now we're saying that the states are completely something written out of in fancy. We are concentrated upon, we are caging, we are boxing, we are saying what is important is action. So how do we write down the source and the goal? So we just have a dummy action called as start, and source is the effect of that action just to write down source, and the finish is something which has no effect, and the goal is the precondition. So that's the problem. You just somehow have to write source and goal. So you take two dummy action, a start and a finish, and then you write down the start source as the effect of the start and goal as the precondition of the finish. So source is the effect of start and goal is the precondition of finish. And let's directly go into implementation of a problem extremely quickly, and we'll see how that goes. So let's take the shortest problem over here, which is of course the flat tire problem. Again, attribution to the authors for providing free images. The images are taken from the book website of Artificial Intelligence, a Modern Approach. That's also a textbook for this course. So now what do we do is, let's write down the source and the goal first. So I've got my start action around here, and it has effects as tire is flat and tire is spare. So let me not write down these things because these are what we set the domain variables, and because they've got to do with just saying what the domain is, let me just write down the atemporal one. So it's at flat comma axle and at spare comma trunk. So the source states, again to mention, that my tire broke down, my vehicle broke down. I had a flat tire at my axle that I need to change it with a spare tire, and my spare tire is currently at the trunk. I also have a finish, which of course will have the goal. So at spare comma axle is goal. Now what I do is I say that there are conditions which are unmet, there are conditions which are unsatisfied, and what I will do is I will satisfy these unmet conditions. This is more generally called as a flaw. We say that this is a complete partial planning graph. So this is a complete partial planning graph. However, it has one flaw. It has something which is unmet. And what I'll do is I will remove this flaw by applying an action. So which action has at spare comma axle at the effects. So this is at object ground. So in order for it, object has to be spare and the ground has to be something, or I could have the put on action which has an effect at t comma axle. That more closely matches us because ground is not a variable but t is a variable. So I can say t is equal to spare, then I'll get at spare comma axle, and I cannot do it over here. So I say put on spare comma axle. So put on spare comma axle. This produces an effect at spare comma axle. So it produces an effect at spare comma axle. Because I'm putting an arrow, I'll not write it down over here immediately under it. You know it by the arrow. If you want, you can write down at spare comma axle. And does it have any more effect? Not at t comma ground, not at spare comma ground. Wonderful. Does it have precondition? Yes. Tire T, that's a atemporal thing, so I won't write it down. At spare comma ground. And it also has a precondition as not at flat comma axle. And it also has not at spare comma axle. Wonderful. So these are what are my preconditions. Now this thing has a special name, and therefore let me write it down around over here. So whenever I write this thing, the nomenclature would be, if I say A1 has an effect P and P is the precondition of P2, and I draw an arrow over here, so I will call it as A1 achieves P for A2. And it's written down like this: A1 achieves P for A2. This is the edge precedence sign. So A1 before A2 because it achieves P for A2. So put on has to be done before finish because it achieves at spare comma axle for finish. So now do you see any flaw? Yes, I do see a flaw. And of course the flaw is what is at spare comma ground. I somehow need to satisfy at spare comma ground. So let me again say, is there a at spare comma ground, at spare comma ground? So at obj comma ground, luckily it's there and obj has to be spare. So at spare comma ground is there. Let's use it. So at spare comma ground is over here. So I say remove and let me not complicate it up. So let's say, where is the spare? It is at the trunk. Spare is at the trunk. So that's what action I do apply. So does it have an effect? So the effects are not at obj comma location, not at spare comma trunk, and the effects is at spare comma ground, at spare comma ground. Here we go. Does it have precondition? Yes, it has at obj comma location, so it has at spare comma ground, at spare comma truck. And luckily this is already satisfied over here. So normally you would have, it can be satisfied by multiple things. Currently I said it's already satisfied. So now there appears to be lesser flaws, so I should be pretty much happy about it, except for the fact that there is another flaw which is not at flat comma axle. So by the way, whenever I draw an arrow and remove it up, normally I'm taking one out of the many options, and all those options, believe me, are states of a normal forward search. So the graph that you see is one of the states, and a forward search is going on. Every time I apply an action out of multiple possible actions and I reduce flaw, I am generating one child in this search where the complete partial graph is one of the states. So not at flat comma axle is one of the flaws that I do need to remove. So let's see, where do I get not at flat comma axle? Not at flat comma axle, I can see it's around over here. So the action is called as leave overnight, and luckily it doesn't have preconditions. So not at flat comma axle is from leave overnight. It doesn't have precondition, but it of course does have some effects, and I will have to be cautious about what the effects are. So let's write down not at spare comma ground. Let me write down just the important ones. So one of the important ones is not at spare comma trunk.